All right, today I will show you some misconceptions about subtracting that will hurt students if they don't understand place value. Here on the board I have 4,300 minus 4,263. Notice I placed multi-digit numbers with zeros when subtracting on purpose because most students struggle with multiple zeros. But if a student understands place value, they'll already have knowledge that 10 ones equal 110. And if they don't, you can go over as a teacher. They should know that 10 tens equal 100. And students should know that 10 hundreds equal 1,000. They must understand this, okay? They must understand this to really understand how to subtract. Now I have it on the board 3 times because I want to show you the mistakes teachers make. All right. Teachers who do not teach place value normally shows a student something like this. We can't subtract 3 from 0. We can't borrow from this 0. So let's go to 3 and borrow 1 from 3. And it leaves you 2. You see how I'm talking? That's not place value language, okay? Because this is not taking 1 from 3. This place values the hundreds, okay? So if you teach them that 10 ones equals 110 and 10 tens equal 100 and 10 hundreds equals 1,000, they will understand that you literally had to take 100, okay, from 300. That leaves you with 2 hundreds, all right? And if they know that 10 tens make 100, well, if I took 100 from 300, well, that's why the 0 in the tens place is 10 tens. Why? Because 10 tens equal 100. You want to make sure your students understand place value, not just marking through numbers. All right. Then you start, repeat the process. Start at the place value of your ones. I cannot subtract 3 ones when I do not have any ones. So I must regroup. Well, your students must understand that 10 ones equals 110. All right. And 10 tens equal 100 and 10 hundreds equals 1,000. So that way when they see, I'm in the tens place, I need to borrow or regroup 110, okay? And I know that 110 equals 10 ones. Well, I need one of these tens, so now I have 9 tens, and I have a great understanding that 110 is 10 ones. You do not want to teach a student to just mark out zeros and put numbers up there without understanding why they are putting the numbers there. So now you're ready to subtract. 10 minus 10 ones minus 3 ones leave me with 7 ones. Notice the place value language. 9 tens minus 6 tens leave me with 3 tens. 2 hundreds minus 2 hundreds leave me with no hundreds. And last, 4,000 minus 4,000 leave me with no thousand. That's understanding place value. You can also, for those students who are just really understand place value, you can use the ones, tens, and hundreds, meaning they can focus on 300 minus 263. Okay? Well, understand that I can take 263 from 300. Well, that's skill in learning and subtraction. Now, understand this. Start with the ones place. Tell your students, can I subtract 3 ones when I do not have any? They'll say no. Notice I have 30 tens. 30 tens. Your student should know place value. 10 ones equals 110 and 10 tens equals 100. Well, I have 30 tens. What is 30 tens? 300. So I can take one of these tens away. So I have 29 tens. Well, with that knowledge that 110 equals 10 ones, I can say that 110 equals 10 ones, so I can regroup, okay? So if you understand place value, notice I can do one place value at a time. I can also advance and enrich my lesson by teaching them deeper place value where they can do 2 digits at one time. As long as you understand place value, you know 30 tens is 300. So you're not taking away the value, still equivalent, still the same. So 10 minus 10 ones minus 3 ones is still 7 ones. But watch this, I have 29 tens minus 26 tens. Well, what do that leave me with? That leave me with 3 tens. And we know place value that 3 tens is 30. See how cool it is? 37. And finally, 4,000 minus 4,000 is no thousand. So you can always teach your students how to subtract. Now, the common misconception students make, they do this. Automatically, they go and say, well, I learned to just cross this out and then make this a 10. And this is the misconception. I want to make sure I make that known. This is a misconception that they can just go and cross out numbers and put 10 there. All right, so they'll say, well, I'm going to cross this out and put 10. I'm going to cross that out and put 10. And I'm going to cross this out and put 2. You don't want to teach a student to just cross out anything, okay? All right, so watch this. They'll say 10 minus 3 is 7. And then they'll say 10 minus 6 is 4, okay? So you don't want to teach students to just mark it out. All right, again, if you establish the understanding, and for me, I could using manipulatives like play money is awesome. Okay, using the base 10 blocks are awesome, and teachers can kill 2 birds with 1 stone. What does that mean? Well, 10 ones. Okay, if I had only 1 10, I would simply have 10. So if I have 1 10, I would simply have 10. But notice if I have 10 tens, well, adding 10 tens is repeated addition. So for a more efficient way is to just multiply, because multiplication is repeated addition. So if I have 10 tens, that gives me 100. Notice that I'm using multiplying by powers of 10. This can be a good extension for students once you build that prior knowledge. Once you build off that prior knowledge. So 10 hundreds, I can repeat and add 10 hundreds, or I can simply use multiplication. So if I have 10 hundreds, I have 1,000. And just to extend the lesson, I can say 10, and you can always say 10 to the power of 1. You have 2, you're multiplying 2. So 2 10, so it's 10 to the power of 2. You're multiplying 10 3 times, so you can say 10 to the power of 3. This is so awesome. And another thing you can extend, if a student struggles with multiplying by the powers of 10, you can say, well, how many zeros do you see in the number 10? And relate it to the exponent, okay? Or you can say, how many zeros do you see in 10 times 10? Well, I see 2 zeros. Well, you can relate it to the exponent too, all right? And you can tell your students, well, how many zeros do you see in 10 times 100? And then they'll say 3, and you can relate it to the exponent in 10 cubed. So just relating it, they should see a pattern in the number of zeros in the multiplication problem when they're multiplying by tens, and a relationship with the exponent. I hope that helped. I'll be back later for more math.